Okay, today, law of cosines. We're going to introduce law of cosines. We'll deal with problem solving on Monday. Um, Huron's formula is another method of finding the area of a triangle. We'll take a quick look at that. So let's jump into this. Skip the page. Here we go. So um, if A, B, and C are measures of the angles of a triangle, and A, B, C, lowercase letters, are the lengths of the sides opposite these angles, then we have three formulas, and notice all these formulas are the same. If you were to take one of these formulas, a squared equals b squared plus c squared minus 2bc cosine a, and rearrange it to solve for a for an angle, you can use this in a couple of different ways. Um, I'm going to pause and walk through the steps so this video is not quite so long. Okay, so all I did was just work the algebra and solve for cosine of A. Keep in mind that this ends up being the inverse cosine of all that mess to find A. B squared plus C squared minus A squared all over 2BC. Um, and again, if you have these handy, it makes it a little bit easier to use. All right, so there's a three-step process that Blitzer likes to have you think about. The number two is always the crucial one here. Use the law of cosines to find the side opposite any given angle. And then two, use the law of sines to find the angle opposite the shorter of the two given sides. This angle is always acute. And then third, find the angle by subtracting the measures of the given angle and the angle found in step 2 from 180 degrees. All right, let's see what we can do about all this. Let's just move this down so we can see it. Solve the triangle shown in the figure, which I didn't give you. We can draw that. When we say solve the triangle, that means we've got to find side A here, measure of angle B, and measure of angle C. So the formula, A squared equals B squared plus C squared minus 2BC cosine A, clearly will require us to plug this into a calculator and take the square root. So I'm just going to plug that in as a square root. So it's going to be A equals the square root of 7 squared plus 8 squared minus 2 times 7 times 8 cosine 120. And now it's a calculator problem. Equals 13. All right, so now we are going to use the law of sines to find B and C. I think I'm going to stop there and let you figure that out. I'll remind you that sine of 120 over 13 equals sine of B over 7, and you can cross multiply and solve from there. All right, so let's take a look at this again from a different perspective now. Notice that in this case, we're given three sides. Make sure as you draw this that the appropriate angles are opposite the appropriate sides. Remember, A is always opposite A, etc. And it's probably, and remember, we're supposed to find all three angles. Measure of angle A, measure of angle B, measure of angle C. It's possible that that angle B, because it's opposite the side that's the longest side could be obtuse. Um, just pay attention to that, um, especially if you're trying to use the law of sines to find the side opposite the longest side. That'll mess you up a little bit. All right, so remember we gave you a formula that said cosine A is equal to um, b squared plus c squared minus a squared all over 2bc. And we want to actually find a, so I'm going to plug that in and say a is equal to the inverse cosine, and we're going to plug those numbers in. Okay, so as we plug those in, I would just directly plug that in as a one big problem in your calculator and come up with the answer. A is equal to 52.4 degrees. Now keep in mind, you guys, here's the mistake that we're going to make plugging this stuff into our calculator, is that if we don't put additional parentheses in here, your order of operations is going to kick in and it's going to give you the wrong answer. Okay. Now that you have an angle, A is 52.4. You can now use the law of sines or the law of cosines to continue to solve this. And I'm going to leave that there to keep this video shorter. You don't necessarily need to see that again. All right, a quick look at Huron's formula, or Hero's formula. And this is simply to find the area of an oblique triangle. Notice that square root of s times s minus a times s minus b times s minus c, where s is defined as the half the perimeter, and a, b, and c are obviously the lengths of the sides. So let's take a quick look at a problem here. We are again trying to find the area. We are given all three sides. First thing we got to do is find s, which is 6 plus 16 plus 18 divided by 2. That equals 20. Now we can just simply plug this into a calculator. And again, nice part is it's a calculator problem. It's the square root of, and remember, it was s times s minus a, so don't forget that. 20 times 20 minus 6 times 20 minus 16 times 20 minus 18. You can plug that directly into a calculator, or you can simplify it if you want. Rounded to the nearest square meter, it was 47.3, which is just simply going to be about 47 meters squared. All right.